name resolution with DNS. In this nugget, we're going to be taking a look at name resolution, specifically for DNS, and we'll start off by taking a look at some of the new Windows Server 2008 features. We'll also take a look at a real dilemma sometimes, and that's where you have the same namespace for your Active Directory domain as you do for the public internet. That's an internal versus external kind of a naming strategy we'll take a look at. Microsoft doesn't actually technically recommend it, but we'll see some ways that we can make it work. Then we'll take a look at some various zone types, primary, secondary, whether or not they're Active Directory integrated. We'll take a look at forwarders. There's a number of different ways to forward queries, whether it's to internet root domain servers or whether it's to something like a conditional forwarder. We'll also take a look here at zone transfers. One of the key things we want to keep in mind there is both availability, but we also want to make sure that it is secure. And then finally, I have to admit that this is a little bit of a lengthier video because I wanted to keep it all in one instead of splitting it in half. So certainly if you need to take a break about partway through, certainly feel free. And with that, let's go ahead and get started. Are you one of those people that has trouble memorizing people's names? I certainly am. I'm just very, very bad at it. In fact, much to my chagrin, my kids' teachers' names in school, I still never really know what they are. I kind of recognize them every now and then as we go to school events and things like that, and I'll say, hey, you, how you doing, chum? Or something equally corny, but I just don't really ever remember their names. My wife, of course, is much better at that than I am, whatever her name is. Anyway, we do run into some problems memorizing names, and similarly, it's difficult for us to be able to memorize all the hosts that are on a network, and that's why we have DNS. Not only, of course, does DNS take care of memorizing the names for us, so to speak, but it also does the translation, of course, between the name and the IP address, because, of course, when you access a resource on the network, you really don't do it by name, even though it looks like it. You really do it by IP address, and, of course, DNS will handle that kind of phone book translation for us. Now, at this level, you already understand really what DNS does, so we're just going to be addressing some things unique to Windows Server 2008 and to planning of your DNS infrastructure. And the first thing I want to look at is the fact that I have a fancy snazzy new pen color, fuchsia or something like that. What can I say? I'm feeling kind of spry today. But we're going to look at the new features of Windows Server 2008, and the first one there is that it supports IP version 6. And that's very important because the world will be turning eventually to IP version 6, just like in lots of parts of Asia and other continents. They're already making a large-scale turn to IP version 6. And one of the things that's important there as well is, for example, the reverse lookup capability to make a reverse lookup zone for that version of IP. Alright then, so how do we go about creating a reverse lookup zone? Well, you could right-click here and choose a new zone, and then as you click on Next, let me go into this, you could choose an IPv6 reverse lookup zone. That's not that much different, really, than what we've done under IP4, but I also want to show you how you can do this from a command line, and I'm just going to do it this way, just so that you know that there's more than one way. I can run the DNSCMD command, and by the way, I'm an administrator of command prompt. Identify the server that I want to perform this on, which is the local server. I could have also put a dot in there, which would have also indicated that it was the local server. And then /zone add, and this is the reverse lookup zone that I'm putting in. And notice that, if the address range that I have starts with FEC0, then of course, since this is reverse, we'll back that up in the opposite direction. Okay, so that's what we've done here. And then IP6.ARPA. Okay, and then /DS primary. So we're making it a directory services integrated primary zone. And it looks like it created everything okay there. So now as I refresh the screen over here, we can see that we now have that particular zone. If you need to change anything about it, some things you can change about it anyway. I can go over here to right-click on it and choose Properties. And then, of course, you can see what it will allow. For example, right now, it's not allowing us to make any dynamic updates. I probably would want to choose secure-only dynamic updates, and I don't really need to do that for right now. But that's something that we'll commonly do in a reverse lookup zone and a forward lookup zone. And then we can also see here the type that it is. Remember, this is where you can also change whether it's a primary zone, secondary, or whatever, and where it's going to be stored, whether it's an Active Directory or whether it's going to be just loaded from a zone file. And a zone file would be the case if I were to clear that checkbox. All right, and then we can also say where it's going to replicate. And right now we're choosing all DNS servers in this domain. We'll again address some of these things a little bit later on as well. There's no real right or wrong answer for any of these things, although in Windows Server 2008 environments it's probably going to be one of these top two options, because this last one's just a concession for a weakness, if you will, with Windows 2000. So that's pretty much how we create, and then later on we can modify this reverse lookup zone. Now if I wanted to manually create a reverse lookup record here, which would also be known as a pointer record, then I could go in here and create one of those as well, manually if I wanted to, by right-clicking here and choosing New Pointer, and then of course I would just enter in the host IP address and name for that as well. So nothing really too terribly different other than the fact that we're working with IP version 6 addresses. Another feature that we have really relates to read-only domain controllers, because remember, I can install a read-only domain controller, which is kind of this equivalent to BDC, or a backup domain controller, that we used to have back in NT4. This means that it will only receive changes to Active Directory, but it can never originate changes to Active Directory. And of course, since Active Directory zones or DNS zones can be stored in Active Directory, we can have an RODC domain controller be a DNS server, but it will also have a read-only copy of the zone. And so it's a primary, not a secondary, but a primary read-only zone. Then we also have something called background zone loading, and this is pretty cool because it's not really something you're going to run into much in smaller to medium-sized organizations, but in really large organizations with huge DNS infrastructure, it could take a long time to restart a DNS server, because what happens is not only do you have to reload the operating system when you restart it, but it also has to load all of its zones, and it can not really do that and operate properly in Windows 2000 and 2003 until all the zones are fully loaded, and then the service starts working for people. Well, in really large organizations, it could take an hour for some of these zones to load because they're so huge. So that really gives you a long period of outage. And even when the zone is loaded, when there's a query made against it, it has to be scanned through sequentially. So what happens now is with background zone loading, once the operating system itself reboots and the services get started, DNS, if it receives a query against a particular record that it hasn't loaded yet, it'll read it directly out of Active Directory while the zone loads in the background. So this is a much better performance, and it helps us to get back on our feet much, much quicker if we've had our DNS server down for some reason. And the next one we have is something called Global Names Zone. Now that's enough of its own feature that I've got a different whiteboard for that one, so let me go ahead and find it. Boy, I got too many. There it is. Too many whiteboard stuff here. The global name zone is useful in this way. Number one, it's useful for flat namespace resolution, okay? Or single label, as they're also called, single label names. And that would be as opposed to a fully qualified domain name, dcnugget1.nuggetlab.com. Instead of a flat namespace, or single label name would be just dcnugget1, without any of the dot stuff at the end. Okay, and you're probably well aware of that. Well, remember, why do we have WINS servers in some networks? Well, that's because we have the ability to resolve flat net BIOS names or single label namespace to an IP address. And there are certain older applications that may still need to use NetBIOS names. So when your clients try to find a flat namespace, how are they going to do that? Well, there's a number of different things that take place there. There's a process of things. Ultimately, they could even broadcast for a flat namespace. But broadcasting is always bad, so we want to avoid it whenever possible. Plus, broadcasting really only works on a single subnet. If you have multiple subnets, that's not going to really work very well for you. So that's why Microsoft came up with WINS, of course, which resolves NetBIOS names to the IP addresses, similar to how DNS will resolve fully qualified domain names to IP addresses and allow us to communicate with the destination. Now, there are a number of problems with WINS. Number one is that WINS, especially in large organizations, gets to be very, very large and unwieldy. And Microsoft has gone through all kinds of things in the past to try to make it a little bit more graceful, but they're really all kind of a Band-Aid on a bullet hole kind of an idea. It's still really kind of dirty, and Microsoft encourages companies to try to phase out WINS. But if you still have those old applications that you, for some reason, cannot get rid of, that depend upon WINS only, then you're going to have to stick with it. Now, here's the problem as well. It does not support IP version 6. So if someone at your company says, your boss says, hey, we're going to get up on IPv6 by the end of next month. Well, guess what, boss? We still have WINS. We still have the flat namespace servers out there, and their clients have applications, or maybe they have an agent or some client piece that accesses that server only by using flat namespace, and it's not able to do it by fully qualified domain name. Well, we're going to be in a real dilemma because in that case, we would need WINS, but we can't use it if we're going to IP version 6. So that creates a problem, and that's why we need global name zone. Now, there's another thing with global name zone here as well. WINS, when I use a WINS server, my clients and servers can update their names in WINS dynamically and automatically, and it's pretty cool in that sense at least. However, with a global name zone, it's not dynamically updated, so it's a manual process. Therefore, this is not something that you want to use for generic workstations and clients like that. You're normally going to use this only for static servers. And let's take a look at other cases where you would want to use a global name zone. Number one, your clients are unable to convert to a fully qualified domain name. I mean, if I am looking for a server called DC1, and maybe I have a little application on my workstation that's looking for a server by that flat namespace, what it will do is it will, in one of the steps for resolving the name, is it'll append a .nuggetlab.com. Okay, and it does that as kind of a concession to this flat namespace, and it says, I wonder if I could find it by a fully qualified domain name, and it'll make that attempt. How do I know it'll do nuggetlab.com? Well, if we go to your Network and Sharing Center, and you start to manage a connection and go to the advanced properties for IP version 4, and I'm quickly going here because you are probably familiar with this somewhat already. Then on the advanced properties under DNS, notice that it says append primary connection DNS suffixes. That's my existing domain, which is nuggetlab.com, so that's going to happen automatically. Now, what I could also do is if I knew that I had to resolve a number of different potential namespaces there for DNS suffixes, I'd add those in here as well. Maybe I have to do accussource.local. And I also have to do, cbtnuggets.com. And so forth. A lot of these different things. Oops, I misspelled that. But anyway, you get the idea there. So I could add a bunch of those things in there. Normally, you want to put the ones at the top that are most likely to be the ones that the clients are going to need to resolve. Otherwise, you'll just use these arrows to switch them around. Now, my objective here is not to show you all of that directly, but it is to point out that your clients will convert a flat namespace to potentially one of those that you have listed in there. But if you have a whole bunch of names that you might have to list, then that can start to have an effect on performance, and it might just not be practical to have a whole bunch of domain names in that. So, if you're not able to list them all, or the client is unable to convert the fully qualified domain name, that could be a problem where you might want to use global name zones instead. Also, you can only use this when all of your DNS servers are Windows Server 2008, because older versions of Windows do not support global name zone, and you normally only use this for registering static servers. Like I said, since it's not dynamic, it's not practical to manually enter in all of your clients, and you probably don't even care about a lot of your clients anyway in that respect. What you want is for people to be able to locate your important application servers instead there. Let's go ahead and take a look here at another thing. Here, I'll show you in just a moment. First, let me cover the last bullet point so I can get rid of this slide. The last thing is maybe you're decommissioning WINS. Okay, and if you're decommissioning WINS but you need to gracefully transition out of it, you can still use global names zone. Okay, and this is going to be a great way to enter in flat namespace without having to keep the investment in WINS servers that are dedicated for only that purpose. Now, let's go ahead and take a look here at global name zone little diagram that I have. Here I've got a little client that's trying to access this server by a flat namespace. Well, among other things, it may have done the .nuggetlab.com, and maybe it's able to find it. Great. However, there may be other spaces where it's not able to do that. For example, if it's not able to do it by that namespace, then instead it may have had to broadcast, little radar-looking things here. It broadcast to eventually find that. Well, here I've got another server down here that it may also need to find, and this is not within the broadcast domain because it's not in the same subnet. So instead, how am I going to find this thing? Well, that might be why I need to have nuggetlab.com DNS server with global name zone in it, because I could add in here net bsrv2, and then this client will be able to resolve that name to this server, okay, in kind of a WINS-esque fashion. Alright then, so how do we go about creating one of these global names zones? And again, this is something that I'm going to go ahead and show you here, because even though as an enterprise admin we're mostly focused on planning and strategizing and things, since this is a new feature, I'm going to go ahead and show us that we just create a normal zone like we probably always have in the past. We'll store this in Active Directory. Normally these are going to be stored in the forest instead of just a single domain, because as indicated earlier, we may try to have to resolve this across multiple domains, so we're going to store it in the forest, and then we'll call this global names, and that's not a variable or something like that. You will want to call it literally global names. Don't just make up your own thing there. And then we're going to go ahead and store this in Active Directory as well, as I mentioned earlier, but it's not really going to accept secure dynamic updates, because remember, it doesn't accept them anyway. So it doesn't really matter what you select here. Even if you choose that first option, it's not going to take dynamic updates. So it almost doesn't matter what you select, but just for intuitive sake, I'll choose the bottom one, because remember, it doesn't do dynamic updates. Now, that's not all we have to do. This thing is not completely ready yet. We would still have to enter in our CNAME records, but even after we'd entered in CNAME records, it still would not be working. And why is that? Well, that's because you have to enter in this command as well, DNSCMD, and then the name of the server. Since I'm on the local server, I just entered in a dot, which identifies the local server, /config. That's important, and I'll tell you why in a moment. And then a / enable global names support. There's two S's there, don't leave that out. And then 1 to turn it on. The reason why I said that the config is important is because there's a lot of Microsoft documentation out there that's wrong on this. One of the biggest books that Microsoft has is written by a really smart guy, and so I don't want to put him down. But it's got like, I don't know, 1,500 pages or something like that on Windows Server 2008. And it's mostly a very good book, but this is wrong. He doesn't have this in there, and you have to have that in there, or else you just get an error message returned when you type this in. And then if you wanted to turn it off, you'd enter in a 0 there. I'm not going to really do that for the time being, but that's what you would have to do. So we've now turned it on. Now all that remains here is to create new CNAME records. So let's just say, and I don't really have one right offhand, but let's just say I did have that one server, netb SRV1, something like that. Then we would have to enter in here the fully qualified domain name for that actual target host. I would enter in its actual FQDN name. So that might be netbsrv1.accusource.local. Okay, maybe that's where it's actually located. Okay, and then that's pretty much it. The rest of these are also, common features that we've probably worked with before. But now what will happen is, if I ever do need to resolve netb server 1, then it will be resolved, available by the global namespace. Now, another issue that you'll run into from time to time is the internal versus external namespace. Because you see, maybe we have a company called nuggetlab.com, and all of my users have email addresses that are, whatever, james.conrad@nuggetlab.com, or something like that. And the users want to be able to identify their company as nuggetlab.com. We also have a public web server. We have a public FTP server. We have a public mail server, all also known as nuggetlab.com. So what do we do about this? Because you see, we have to be able to resolve names to the internet public for our public internet servers, and we also have to be able to resolve names for our own internal network, so that we can find our domain controllers, and our file servers, and our print servers, and all those other kinds of things. Well, that would normally result in people, sometimes ignorantly, or usually ignorantly, creating something called an overlapping namespace. Let me show you what that kind of looks like here. This is something that is not recommended. But here we have nuggetlab.com in our internal network, nuggetlab.com in our DMZ. And by the way, the DMZ would be separated by, I'm just putting like a Cisco firewall here. There's the internet, Cisco firewall here. This is an ISA server, which is a Microsoft product, which normally acts as a firewall as well and as a proxy. So my DMZ would be, between these lines here. Okay, so this would be my DMZ. Also known as a perimeter network or a screened network or something like that. Okay, so here we have this situation where we've got our public name server out here, nuggetlab.com, and it's got, trying to resolve for our www server and our MX server, our mail server. And then here internally we've got, our file server and a bunch of other things that we have that our clients need to be able to access. Now, if I have all of these records on both of these servers. One thing that might be easy to configure would be to just make these Active Directory integrated, and then I would have the same data, same zone data on both of these, and it would collect all of these hosts and all of these hosts and all of my clients and everything in one big zone. That becomes a problem. Why? Because maybe this is client 01 right here. Client 01. Because now my hosts on the internet, they can perform queries against this DNS server, and they might be able to probe my internal network and to look for client 01. Once they've got a name, then they can start performing attacks against it. They might be able to find my file server and steal data off of it. So the key here is I do not want the internet public to be able to see a DNS server that can resolve my internal names. That is insecure. Okay, that would be a problem. Likewise, however, my internal clients here, they want to access my web server. They need to access the mail server. They need to access other things that might be here in my DMZ. So how do I get these records on this server? Okay, so these are some kind of dilemmas that we have to come up with. Microsoft overall does not like this. This is called an overlapping namespace, where I have the same name internally as I do externally. And let's take a look at some of the ideas that Microsoft has to resolve that. Number one is to use a different top-level domain. Now, if we go back to this, we'll see that we got nuggetlab.com both internally and externally. Well, the internet public probably likes .com most often, so what we could do is to change this to whatever else. .net, .local would be better, because .net is still routable on the internet. So .local, .corp. If it's a Microsoft domain, we can make it .msft. Anything else you want, as long as it's not the same as this one. Okay, that would be a good way to resolve that. And then another thing that you could do is, if you decide to go with one of these other types of top-level domains, then what you could do is to make sure that your clients are still able to get the warm, fuzzy feeling of nuggetlab.com by entering in a UPN suffix for them that's also nuggetlab.com. And we talked about that in a previous place in our same series here. So that's what we could do, alternate user principal name. Now another thing, and I don't really have it on the slide right here on this whiteboard, but another thing we could do, which I like quite a lot, is to just make this a child domain. So maybe we left it as the way it was. Let me kind of undo everything here. Maybe we left this at nuggetlab.com, but instead of making it exactly the same, we made this, child.nuggetlab.com. Okay, so and that can be the root of your namespace, the root of your Active Directory domain, and the root of the forest could be child.nuggetlab.com. It doesn't have to be only the first name in the namespace. Okay, I could make this the root of the forest as well in Active Directory here, and make this just a primary DNS server out there on its own. Now then, let me go ahead and clean up here. All those things being considered, if we, for some reason, are not able to win the battle, maybe it's political or something like that, and we cannot seem to talk our boss maybe into going with like a child namespace or .local or something like that, then we might have to use split DNS. And this is where we do have overlapping namespace, and we have to figure out a way to live with it. What we could do is to have an internal zone that has a CNAME record for the DMZ hosts. Okay, they will be totally different. Going to be totally different DNS servers. They're not going to be Active Directory integrated. Okay, so this was probably going to be Active Directory integrated, just as usual in Active Directory. This one is going to be a DNS server that's just a standard primary. So, as a result of that, they're not going to replicate back and forth, and therefore, this one's not going to receive the host records for all of my internal clients and protected servers. But what I would need to do is to be able to make sure that this one could resolve any names that are out here like we drew in earlier, my FTP, my web, my MX server, all of those things. And what we could do is to export the names from here, and we could import them over here so that we could add in the A records for that, or we could enter in CNAME records, and that would also work as well. So we have to have a CNAME for our DMZ host. We could do that, or we could import those with a script. Now, I'm not really big on the scripting item, but I did find some script, a little code for you here that you can use if you want to, and I'm in the wrong place, so let me go find it. Still in the wrong place. Here we go. An IP DNS import script. This is just a sample script for you to use if you wanted to, and I'm assuming It'd be nice if I could spell right. I'm assuming if you had a file called dns.txt, then if these were the servers that are out in my DMZ here, and those were their IP addresses, then I could use this script to be able to bring those in. And I would, of course, run this on my existing DNS server here. Okay. Now, the other thing you want to keep in mind with this, though, is that you do not want to allow zone transfers. So, I would not want to allow zone transfers from my Active Directory server to nuggetlab.com. That can be done a number of different ways. Number one, my ISA server, which acts as a firewall, I might be able to block TCP53 so that it would not have an inbound TCP53 query to this server. And the reason why I mention that is because zone transfers take place over TCP53. So again, the key thing there is do not do a zone transfer from the internal domain to the external domain, because then you expose your internal clients to the public internet. And then again, it's a little bit beyond our scope as far as configuration and setting up and everything, but in the method that I've shown you here, Microsoft says that it requires an ISA server. I'm not sure I quite see that it requires an ISA server, but they say that it does. Maybe they're just trying to sell us another server. I don't know. Now, we have taken a look at various zone types before, but let's just do a quick review here. First of all, the first one you're probably going to use most often is the primary Active Directory integrated zone, and there's 3 different ways of storing that data in Active Directory. The first one is all domain controllers, which is a concession to Windows 2000 because it doesn't have a domain DNS zones partition or a forest DNS zones partition to be able to store the data in. It has to just store it like all in Active Directory. You can also store all DNS servers in the domain or all DNS servers in the forest. If you only have a single domain in your forest, doesn't matter. These pretty much function the same way. But if you do have a forested infrastructure with child domains and multiple trees perhaps, then you're going to have more data to replicate from one DNS server to the next, because it's going to have to keep track of all of your DNS zones through all of your DNS domains. So just going to be more replication data there in the forest. And you just have to strategize that a little bit, because, for example, here if I've got a big hub and I got a little tiny branch office here and it's got a DNS server, and we really only care about resolving names on our own domain down here, but up here I've got a gigantic hub location, and we've got all kinds of other domains, in different sites and everything like that. And then we might have, if we're storing all the zone data in the DNS forest for all of our zones, then this poor little DNS server down here has to pull zone data from all of our other domains, because they're being stored in the forest, has to pull it all down here. Even if we don't care about these other domains, we really only need to resolve in our own little space. So that's something to keep track of and know about in that respect. Also, there's a primary read-only. This is more of a what we looked at earlier when we talked about read-only domain controllers, because and this could be another example of that if we're in a small branch office. We don't want to pull down a lot of replication data here or send replication data because we're only receiving data. It's read-only. We can only the only writes that take place are replicated writes into it, but it never can originate a change and replicate out. So that's the primary read-only type. And we will address that a couple of times in this series. And then there's a primary zone file. This might be the case if I have a traditional type of a DNS server, or one that I want to be able to replicate to some other brand of a DNS server. Now, there are other ways of doing that, because you can have bind secondaries and things like this, but you could have a primary zone file type of a zone, and that would be a non-Active Directory integrated. This would also be the case if maybe I'm hosting, web servers for a business partner or for somebody else, and they're not part of my Active Directory domains or part of my Active Directory zones, so I'm just going to create a primary zone file type of a zone for them. Also, I could have a secondary zone, and this would be one that simply receives updates from the primary. Okay, so you can pull zone data in a zone transfer from the primary. And by the way, you don't have to pull only from a primary. You could have, underneath that, another secondary. And the secondary down here may be able to pull its zone data from this secondary. Okay, so it kind of can daisy chain here as well. Of course, the more you do that, and the further down you go in different generations of secondary, the longer it's going to take to get convergence with your zone file. Now let's also take a look at dynamic update, which we alluded to a little bit earlier. The key thing here is going to be the security of it. So if I go to a zone right here and go to its properties, notice that it says it's going to accept only secure dynamic updates. That means that it's only going to accept updates from trusted sources, which are going to be workstations and servers in my own domain that are part of my domain and that can be authenticated as such. Okay. Anything else would be non-secure and secure, and that would mean that anybody that wanted to register a name with my zone could do so. And they could potentially, if they've got malicious intent, register a whole slew of invalid names and cause a lot of network problems there. So rarely, if ever, can I think of a reason why I'd want to choose non-secure and secure. Or you could choose none if you didn't want to allow dynamic updates at all. But of course, in a normal production Active Directory environment, for like NuggetLab.com, which is my normal Active Directory production domain and zone, then I'm normally going to want to allow secure dynamic updates. Also, there's DHCP and the DNS update proxy item. Let me talk a little bit about that. Let's take a look at how that DNS update proxy item relates to us. You see, here I might have an old client. Maybe this is a Windows 98 client, heaven forbid, something like that. Well, the Windows 98 clients, when they receive an IP address from the DHCP server, they're not able to automatically register themselves with the DNS server using dynamic update. Certainly not with secure dynamic update. So what could happen instead is we can configure our DHCP server to register the A record and the pointer record with the DNS server on behalf of this client. And then this DHCP server becomes the owner of those two records. Okay. Now then we get into a problem though, because what if this DHCP server went down for some reason and we replaced it with another DHCP server? And then, when this client came online, it got a totally different IP address from this DHCP server than what it had before. Well, since this DHCP server does not own the record that was originally updated here, it can never update that record because it doesn't own it, and that becomes then a stale record, and we can never get good data up there. Okay, so that's one situation that could happen. The other thing that could happen is, maybe this is a good DHCP server, this client did get an address and we successfully registered everything, but then we decided, hey, let's get with the times. We're a little bit late here, but let's update this server here to a Vista machine. Certainly, Vista machines can update their own records on DNS. So it tries to update its records, but guess what? It is not the owner of these records up here on DNS because a DHCP server did it for them originally. So now, again, we'll wind up possibly with stale records up here with old IP address references, and this client will never be able to update that. So that's where the DNS update proxy item comes in handy. And the way it works is that what I'll do is I'll create a user account. Let me actually back some stuff up here. Get a little bit cleaned up here. What I'll do is actually create a user account, and I'll put that user account inside of the group membership for the DNS Update Proxy Security Group. Then I'll run the DHCP service under this user account who happens to belong to that group. Then, when I create a record up here, and I'll just put, a record here and a record here. Maybe this is my A record, and this is my, PTR record. When I create these, I'm the owner of those. And this is not a user that actually logs on. It's just for use of the service. But this user is actually the owner of these, and they're members of that DNS Update Proxy Security Group. So, if this server were to fail, or I replaced it for any reason, then I would still start this DHCP server up, and I would also start it using the same exact user account, which is still a member of that group. Therefore, when they try to update these records, they own them because they owned them over here, and they still own them, so they can update them, of course. And just so we can put eyeballs on that account, let's go here to Server Manager. And there's a DNS Update Proxy Security Group that's right here in the Users in Active Directory. And then in order to configure that, here I've gone to a server that I actually have DHCP running on. If I go to the Properties and go to the Advanced section here, then I'll enter in credentials. Notice DNS Dynamic Update Registration Credentials. I'll enter in whichever account that I created here along with its domain and password. And of course, as with other types of service accounts, these would be a complicated password, a complex long password that does not ever expire, because if it did, then of course that service would stop performing. So that's how we can use the DNS Update Proxy Security Group, and to make sure that we are always able to update records that have been made in the past. Now let's also take a look at some different zone types that you'll also see as well. One of those would be delegations. We already, I think, saw that in a previous nugget when we went into our DNS here for our forward lookup zones. And remember, we went to nuggetlab.com and we had to create a west delegation. Why did we do that? Because we were about to create a child domain called west.nuggetlab.com, and we had to have a delegation here for that, which would then point to whatever that DNS server was going to be. So you don't have to create these technically in advance. The domain will still build okay, but you're usually better off to build these in advance. And as a quick refresher, I could do that by choosing to right-click in my existing zone for nuggetlab.com, and I'll choose new delegation for the child zone that I'm about to create. So then I'll click on next, and in this case, maybe it would be east.nuggetlab.com, and then I would add in the server, 10.10.10.5 or whatever it is. Actually, it'd have to be the fully qualified domain name there, wouldn't it? So that would be the name of the server, and then I'd enter in the IP address here. You don't have to enter in a name if you don't want to. Just if you do, and then you hit resolve, it'll give you the IP address down here. And then I'll enter in the time to live and so forth. Now, of course, I don't actually have an IP, a server that exists that can service that, but you get the idea. So there's our delegations. Now, the key there is that when you create these delegations, it only has the name of the authoritative name server. Notice that I don't have to replicate all of the other data at this point. I don't have to replicate all the other Active Directory zone information within it. I just have a pointer to whichever server is authoritative for that zone. So that's the way we work with these. Okay, and again, it points to a child domain. You do normally want to configure these before. I guess I've been texting too much. Before a child, before you perform DC promo on the child domain. Now, there's another kind of a zone that you can create as well, and that would be a stub zone. I kind of like these a lot. These were new with Windows Server 2003, but they're not new in DNS. They've been used by other operating systems for a long time, and Microsoft finally caught on in Windows Server 2003. One of the things I like about these is that they're automatic. You see, with the delegation, when I enter in the authoritative name server, if that changes, I have to go back in there and manually change that. But with the stub zone, it automatically changes it. This allows me to avoid replicating the domain DNS zone. Maybe I don't want the replication of all of those records. I just want to be able to resolve whatever the stub zone is, but I don't want all of its associated baggage and all of the replication and all of the other stuff that comes along with it. I just want to be able to get there if I need to. Okay? And I also don't have to replicate the forest DNS zone. Let's go ahead and take a look at how we can work with a stub zone. And one of the things we'll have to do is, let me go to a command prompt here, is to identify an authoritative name server. So if I do ns lookup, and go to an ns lookup command prompt, then I'll set the type. You don't have to memorize this. I'm just doing this to demonstrate something for you. It's not really particularly on the exam, but I'm setting the type to ns. Name server, okay? Name server, and I want to know the name servers for google.com, okay? Somebody at Microsoft told me, a contractor at Microsoft just insisted that you had to be able to have authority in the domain for which you wanted to create a stub zone. Well, that's not really true at all. Look, I've looked up the NS records for Google, and I'll just use one of these. You don't have to use all of these. I'm just going to use one of these, and then I can use one to update the rest of these. So, see if I can memorize this. I'm not very good at memorizing things, like names, like I told you before, or IP addresses. But I got that IP address. Now what I'm going to do is I'm going to create a stub zone here for that domain. So I'm going to right-click, choose New, hit next. I'm going to create a stub zone for google.com. And I can store this in the Active Directory partition if I want to. And this is not really entirely practical. I might do this if I had my users that constantly were accessing all kinds of things like Google Docs, which is kind of their version of Microsoft Office documents, and Google, Gmail, and all of the kinds of things that Google might service for us. Maybe we've got some kind of a partnership where we depend upon them for a lot of services. Well, if that's the case, I might want to have a stub zone for Google so that it's easily accessible and we don't have to constantly go out to the internet to resolve. Okay, so I can replicate this to all servers in the domain or in the forest, doesn't matter either way right now. And then I'm entering in the name of the zone, google.com. Okay, and then I'm going to enter in the master DNS server, and I've just pasted in the IP address there, and notice that it did resolve it properly. Then here's what I can do, and this is where this gets to be an additional layer of, pretty cool stuff. I can use the above server to create a local list of master servers. That way I can get all of the servers there in my stub zone. So I'll click on next and finish, and then when I go to google.com, notice that it brought all of these in. That's because of that last checkbox I showed you. It used it to pull in all of the master servers. And by the way, just so your eyes aren't playing tricks on you, we generally go to the end. They're all ending in 10, but notice that this is where they're different, in the third octet. So they're not the same IP address, even though it kind of looks like it initially. Now what's going on here as well is, the key thing is we get the start of authority record and the name servers. Okay, the start of authority tells us, identifies this as the authoritative servers. It also identifies the time to live, such as how long any names that are resolved by these name servers are valid for, like a day or something. Then the other advantage we have here is it also gives us these actual host records. These are known as glue records. If I create a delegation, or if I create a stub zone, in this particular case the stub zone of course, the host records are glue records is what they're called, which of course just point to the actual name servers. Then if I needed to resolve something like, server5.google.com, then the stub zone would point me to one of these servers, and it would do it kind of in a round-robin fashion, and then one of them would resolve that name for me. And then we've already seen reverse lookups, but I'm just going to go ahead and create a reverse lookup zone for a version 4 reverse lookup. So if I go down here, we should be able to see this. Expand things out a little bit. And then I'm going to do it right here. So I'll just create a new zone, and I'm currently in the 10.10.10 subnet. So I'm going to create a primary zone, and again I'm going to just store it in the domain in this case, but for us will work just as well in my case. It's a reverse lookup zone, and we're going to enter everything here in backwards. So since I'm on the 10.10.10 network, I'm going to enter it in backwards, and I'm going to go 10.10.10 instead. Okay, okay, it's kind of a joke. Just like Bob spelled backwards is the same, right? Okay, but in reality, if my IP address range was 10.9.8, for example, then it would be 8.9.10, like that. Okay, so you enter these in backwards in all cases. And then we'll go ahead and click next, and then we can allow secure dynamic updates, which is a good idea in most cases if you have Active Directory integrated zones and you want your clients to automatically update themselves, and then you just simply click next and finish. And now what I'll have here is, in my existing zone, if I've got Vista Client 01 here, for example, one of the things that I might want to do is, when I create these, I want to update the associated pointer records. Okay, so I can then click OK, and that would then be able to update its pointer record. And the pointer records are what actually go in these reverse lookup zones. Now, the other thing here is, and we can see that, there it is now. The other thing is we could manually create one and right-click to create a new PTR or pointer record, and then you just enter in that information manually, similar to what you saw me do for the IPv6 ones. And of course, the usefulness of these reverse lookup zones is that you can identify which host it is that's doing something. For example, maybe I'm getting a lot of activity from that 10.10.10.42 IP address, but I don't really know who that is. Maybe they're broadcasting a lot, or it looks like they're attempting to do a denial of service attack. I'm getting a lot of activity from it. So I go to a ping-a and then 10.10.10.42, and it should resolve the name, which it did right there. VistaClient01.nugalab.com. It was able to tell me who owned that IP address because I have a reverse lookup zone and a reverse lookup pointer entry for that particular host. Now let's take a look at how forwarding takes place, and in general, how resolution takes place, for example, on the Internet. It all starts with the Internet root, and this is often designated as simply a dot server. That's why I've got quotations with a dot under there, otherwise it might be a little harder to see. Looks like I made an unhappy smiley face or something. But anyway, you get the idea. Sometimes these are also combined with another level of server known as a top-level domain server. Here, let me just go to a picture of it. Here we go, like this. Okay, so let's say that this client right here wants to find www.west.accusource.net, and that's a web server that's down here in west.accusource.net. So they enter that into their browser, for example. Well, this is the progression of events that takes place. NuggetLab.com, which is their DNS server and also their domain controller, it doesn't have Accusource anything, so it doesn't know. So what it'll do is it'll forward it out to whatever its pre-configured forwarder is. Very often that'll be either root hints, which would take us up to this, root hints, on the internet, or it'll take us to our ISP. Okay, so in many cases, if you just leave everything as default and you don't configure an ISP, it'll immediately go out here. Okay, and of course it goes with the firewall, but you get the idea. Then the top level server says, well, I don't look for Accusource.net. All I do was I just look for the .net part, and I also know about where to find the .net server. So it'll send my query down here to .net. Now it could also easily send it to a .com server and so forth. And in many cases, these two roles, the root, like I said here, just the dot, and the .net, .com, .gov, .org, .whatever, are all on the same server. But in this case, I just differentiated them. So then the .net server says, well, I know where Accusource.net is, and so it'll refer me down here, and then I got Accusource.net, and then it'll refer me down here to west.accusource.net. So you can see it kind of just goes down the chain. Now I can configure my DNS server to require recursion. This means that it will not send all of these referrals back to the client. See, what would otherwise happen is this client here would take the onus of keep going back and forth to each one of these DNS servers to get the referrals from them. But if I make it recursive, that means that this NuggetLab.com DNS server is fully responsible for getting it resolved. So what I'll do on the client side, all it does is it sends the query, and it waits for a moment, and then it gets an answer, and that's all it knows. But the NuggetLab.com server, it's the one that's doing all of the queries out here, and it's the one that's getting all of the referrals. Now, another thing that could happen, let me clean up a little bit here, is that to speed things up a little bit or to make them more efficient, rather than constantly going out to root servers and then the top-level domain servers and all of this process, what I could do instead is I could configure this DNS server to point to my ISP's DNS server, because chances are, if this is a busy ISP, it's probably already resolved everything that I would ever need in the last 24 hours. So it's probably already resolved west.accusource.net at some point in the past day. So it'll still have that in its cache, and then it will just immediately send me the answer back without having to go through all of this stuff out here. Now, as we continue on with our forwarders, let's take a look at another thing here as well, and that's Windows 2000. Windows 2000 was kind of a weird thing, and I'm just telling you this just if you need to fix any of it in your own organization. Hopefully it's all been fixed by now. But with this whole thing, you see, remember our top-level root server here? In Windows 2000, what happened was, if this was a Windows 2000 server, it not only had its own zone of NuggetLab.com, it also had built into it the dot. So initially what happened is administrators would install Windows 2000 domain controllers with DNS on them, and then my users here would try to find Accusource.net or Google.com or whatever, and the only place they could go would be to this root server, because if you hit the root, then you know that there's no higher level of authority, so you're not even going to try anything else. So the queries would often die on these Windows 2000 DNS servers and never make it out to the internet. Well, that was a very unpopular thing, and that got fixed pretty quick. So what administrators had to do was they had to delete the root zone off of the Windows 2000 servers, use the root hints instead, which would then take us through this normal process. Now, it could be also that you actually want your users to stop at this .dot server right here. That doesn't happen very often. But if you don't want your users to ever access the internet for whatever reason, maybe it's a classroom, maybe it's a set of kiosks or something like that, then you can point them to this DNS server, and this DNS server has a dot in the root. Well, then it can only resolve names within its own namespace, within its own zones that it has on this DNS server, and it'll never get resolved internet names. So that's where we would force it to an internal address only, or to an internal root server. And then we could also redirect to a busy DNS or ISP. And this is what I talked about a little bit earlier, where I could, instead of taking NuggetLab.com and sending its forwarders out to root hints, which would be out here, instead we'll just send it to our own ISP, which we know has probably already resolved everything under the sun, and we'll just use what it's already got cached and get a much quicker result back. And the way we would do that would be in Server Manager, and this will be just a quick review for you. you. And I'll go to the properties here and forwarders. Now you can see here I've already configured that. What I've got in my network here is I've got two totally separate forests and totally separate entities, and this 10.10.10.5 server is actually a name server for my accusource.local domain, but it also resolves to root hints out on the internet. So in DC Nugget 1, which is my existing DNS server for all of our demonstrations, if it's not able to resolve a name out of its own zones, instead of going out to root hints, it'll go to this server, which will then in turn go out to the internet. Okay, so this is going to be how I've configured it there. If you want to add more, of course, you could do that here as well. Now, if I did not have this, if I edit this and I were to select that and then deleted it, like this, now I don't have anything there, I'll just apply. Now what's going to happen is it's going to go to root hints and root hints only. By the way, even when I did have it there, if I had to check this box while I still had an address in there, if it was unavailable, like maybe that server was down for maintenance and it didn't get a response from it, then it would fail over to going to root hints right here instead. Now in this case, I don't have any forwarders anymore, so I do need to go to root hints, and these are just commonly known root hint servers out there on the internet, and there's their IP addresses. You used to have to update these manually if you ran into, because these could get outdated and stuff, but now they should be updated automatically through Windows Update. Another thing you could do would be to use a caching-only server, and if I go back to my little diagram here, it could be that this ISP, maybe it's a caching-only server. It doesn't even have its own zones, and because it's always servicing requests for companies and home users and all different kinds of internet customers, that it's already resolving a lot of these names out here, then this could be configured as a caching only server, and the way that's configured is really easy. The way you do it is you don't do anything. You simply install DNS here, and then you've got your server here, but you never configure any forward lookup zones, or any zones. You don't configure any zones whatsoever, and then what happens is when any queries come up against this server, it'll resolve them, going through the top level domains and through that whole process. Then it will simply cache those queries. If I go to view in advanced, which you can see I've already done here, then we can see down here that we've already got some queried different ones here that I've gone to. Boy, hopefully I haven't embarrassed myself anywhere. Fortunately, I think I've just been looking for music. So anyway, that's the ones that are already there. And you can see any, .local. You can see I've got AccuSource because that's my other server on this network, and I access shares over there and stuff. So you can see these are all cached. Now, incidentally, of course, if any of these get stale, if you suspect that it's trying to resolve against old addresses that don't actually exist anymore, you can right-click here on the server and choose to clear the cache, and now you'll see that I really have nothing. I just have the root servers now, the left over. The other thing I could do is if I wanted to do that from a command prompt, and I'm just kind of freestyling here, I'm just showing you just other information, FYI, I could do DNSCMD /clear cache. And that would also clear that cache out. Now, another thing I could do would be to configure a conditional forwarder, and that would be for a specific given namespace. So rather than pointing to something like my ISP's DNS server or to a specific server that way, instead what I'll do is, let me go this way, is to point it to an exact DNS server that I know that's out there that can authoritatively resolve a name. So, for example, if I'm looking for, I'm going to use accusource.local in my example here, even though it's not directly resolvable on the internet, but I have it on my network, so I'll show it to you. But if I already know that I want to use this server to resolve that zone, then here's how I would configure that. I'd go to conditional forwarders in DNS, choose a new conditional forwarder, and say accusource.local. Okay, and then I'll go ahead and add the IP address for the server that I know that can resolve that. Okay, and then we have it there, and that's it. Now, another thing I could do is, if I know that we need to access this a lot, and maybe all of my DNS servers I want to be able to resolve it, then I'll store this forwarder in Active Directory and replicate it to, the same options that we have for all the other kinds of replication. Okay, and then if it times out, okay, which could happen, then it can go to other methods such as root hints to be able to further try to resolve that query. So now what's going to happen is anytime it tries to resolve anything against accusource.local's zone, it'll use this specific DNS server to resolve that zone. Now here I want to quickly revisit the issue of a caching-only server, because you see, if you're in a situation where you have maybe a big hub with a very busy domain here of nuggetlab.com, and then you've got a branch office here separated by a slow WAN link, it might be advisable that instead of making this another nuggetlab.com DNS server, which replicates all the zone data back and forth across this slow WAN link, it might be better to make it a caching-only server. So remember, that's a DNS server that has no zones of its own. Okay. And then what will happen is when clients try to query against something in nuggetlab.com, this will have to go to the nuggetlab.com server up here, and you probably would have a conditional forward for it or something for nuggetlab.com. So then it would go to this DNS server, resolve it, and bring it back. Now, we did have to use the WAN link for that, but now it's cached. So any other clients that try to resolve that same name will be able to just use the cache on this caching-only server. Then when we have internet queries we need to make, such as maybe cbtnuggets.com out here, cbtnuggets.com out on the internet, well, these same clients will again hit this DNS server, but since it doesn't hold the zone, it'll go to, it's configured either root hints out this direction, or it might be better off for it to go to our nuggetlab.com server here, which would then in turn go out to root hints, because since this is probably a very busy DNS server, it's probably already reserved a lot of, or rather resolved a lot of those names, and it may already have those cached as well. Since it's already got the name, and whatever the case, since it resolves the name, then it will send the answer back to this caching-only server, and once again, it'll now store that here on the caching-only server. Then when my clients here need to access cbtnuggets.com a second time, it'll be able to go directly out to the internet and directly to my cbtnuggets.com server. Now, for exam purposes, the thing that I would keep in mind here is that if you're separated by a slow WAN link and you don't want to replicate a lot of zone data across that slow WAN link, but you still want reasonably good or fast performance, the rule of thumb is you can very often install a caching-only DNS server, and I would be well aware of that. Now let's go ahead and conclude here with some information about zone transfers, availability, things like this. Now the first thing here is, of course, again in my DMZ or screen subnet or perimeter network, all called, I'll have a nuggetlab.com DNS name server. Now, I have to have that here in order to be able to make it available to the internet out here, and so that they can find my mail server, web server, and the like. In order for my clients out here on the internet to be able to query against this server, I have to have UDP 53 open. Okay. If that's blocked, then they will never be able to query against this server. So that's always going to be open in almost any circumstance. The thing is, though, I do want to keep TCP 53 closed, and the reason for that is because zone transfers take place over that port, and if someone were to come out, with a DNS server out here and to try to impersonate or something like that, and then try to get me to zone transfer out to them all of my records, well, of course, that could potentially be security sensitive, so we'd want to keep TCP 53 closed. Now, how would we do that, by the way, just as a quick review? Well, you go to whichever zones you're trying to host, and here, of course, we've got nuggetlab.com. If I go to the properties of this and go to zone transfers, then we'll see that we do not allow zone transfers at this case. If I did have other DNS name servers out there, and this of course is my Active Directory zone for internal clients, but if you'll work with me for a moment here and assume that this was our public internet DNS server, then we would possibly allow zone transfers. We do not ever, I can't think of a good reason, to ever say any server right here. So you can either do one of these other two options. Number one, only to the following servers, and then you would edit this option, and you would add in the IP addresses of your other DNS servers that you wanted to be able to host that same zone. Or you could say only to the servers listed on the name servers tab, and that's very often what I'll do. And then I'll go to name servers over here. These name servers will be anything that I could add in as authoritative name servers, may already be stored in the SOA record, or I can manually add them in here and just again add in the fully qualified domain name and resolve that to an IP address if I want here as well. So of course the advantage of this would be that then I can strictly limit the scope of zone transfers to anything that's on the name servers tab, which I just discussed, or only specifically identified name servers there as well. So, doing that kind of a method will keep my name server both available and secure. Now, another thing that you might note here, and you can kind of see that I've mentioned this here, this is a secondary DNS server. You don't have to do it this way. This is just another idea to potentially enhance security. Here I've got my public nuggetlab.com server here, name server. And this is just using a zone file. It's not Active Directory integrated or anything, but it's my public nuggetlab.com. It's got my web server IP address in there. It's got my FTP mail server and the like. And this is going to be the primary copy of the zone. So what I'm going to do here then is I'm going to zone transfer to this secondary out here. Why would I want to do that? That's because it's an additional layer of security. So that just in case somebody figures out a way through my firewall or hacks this somehow, we wouldn't want them to pollute the records on this name server right here. If it were a primary, then it would be potentially possible that they could write changes to it, because that's the nature of a primary, is that it can accept write changes. By making it a secondary, even if they get past this first firewall, well, they still can't make any changes to it. Of course, there's other things they can do, denial of service attacks and what have you. At least they can't make changes. Now, but by making this one a primary and this one a secondary, our zone transfers only go this direction. And of course, in order to make that happen, in this case, I do have to make sure that TCP53 is open so that I can have a zone transfer that way. And of course, depending on your firewalls or your router configuration, you can also set up TCP53 so that it only goes one direction and that it's blocked going this direction. So you can configure that as well. And then, of course, I would want my UDP53 open on this firewall as well, so that we could query against not only our own name servers here, or we could also query against public DNS name servers or ISP and the like. And then, of course, totally separately, even though they're named nuggetlab.com, they're actually different in the sense that these would be my Active Directory integrated. These are probably both domain controllers and DNS servers, and they don't really have a direct relationship to this nuggetlab.com server here, except that, again, we might export the records here for our www server and our FTP and our web, mail server and all of that over to these, or just as well, we could also create CNAME records ourselves, just manually, to whatever our servers are out here, again, our web server and the like. And remember that may also require that this firewall right here, or some equivalent somewhere in this DMZ, would be an ISA server from Microsoft. In this nugget, we took a look at name resolution specifically with DNS in mind. One of the first things we took a look at was some of the new features of Windows Server 2008, such as the kind of support that it has for IPv6, for single label names, those sorts of things, some really glossy new things there. And then we took a look at the internal versus external naming strategy. Wow, that's a dilemma that Microsoft has officially said you should try to avoid, but boy, a lot of people use it. So we took a look at how to resolve that if you have the same internal namespace as you do externally. Then we took a look at the various zone types, primaries, secondaries, those sorts of things. And then we looked also at forwarders. Remember that you can use things such as conditional forwarders, or you can forward queries to maybe your ISP for performance purposes instead of having to go out to internet top-level domain servers. So lots of different things we can do for that. And then we looked at zone transfers. Remember, with zone transfers, one of the things you want, of course, is to make sure that you have up-to-date data, such as from a primary to a secondary. But you also want to make sure that it is secure and no one can either pollute it or retrieve records from one of your servers. Well, I hope this has been informative for you, and I'd like to thank you for viewing.